13.1 as well as start 13.5 today. What I want to do is talk about angles of elevation and depression, and then we skip to the trig stuff now. 13.1. This is still 13.1. It's still a little bit of it here. So what happens here is we're going to finish with these angles of elevation, angles of depression problems, which most people find to be, well, pretty easy. And then I'm going to talk about briefly law of sines again. What we're going to do today as far as the law of sines is concerned is identical to what you guys did last year in geometry. The law of sines will always work. Tomorrow we're going to talk about what's called the ambiguous case of the law of sines. It's when you have the possibility of it not working, or its possibility of giving you multiple triangles. There's some little things that have to occur in order for that to happen. I'll have to show you guys why that occurs. It's really not that difficult to work with. That'll get us time for Friday then to do law of cosines, and then I don't know, we'll see where we're at come Monday.
Are you going to watch a movie?
Why? No.
Go to the Institute of Triangles.
We're not going to go to the Institute of Triangles, nor is there a place called the Institute of Triangles. So stop wasting my oxygen.
Do you want to bet?
No.
I'll bet you like $3.
So angles of elevation, angles of depression. This is a very easy concept to think about. When you guys did this last year in geometry, one of the easiest ways to think of is line of sight. If you're looking just straight ahead, it's an imaginary horizontal line to the wall. You agree? The minute you look up, it's got an elevation to it, right? Pretty crazy, isn't it? Now, those of you guys that did that lab in the auditorium last year, that's what you were doing.
That was annoying.
You were working with your angles of elevation with the clinometer, with the upside down protractor. Okay? You were using what, in essence, is rudimentary surveying equipment. You were able to find distances and calculate heights with what people do with the sticks in the middle of the road and the laser sights. Austin Freeman was talking today with one of the problems we have for golf, the golf sighting. It tells you the slope of the hole. It tells you the distances. All it's doing is shooting the laser to a spot on the flagpole, and it's calculating all this trig on the machine. Ben Sechel, you guys know Ben? Graduated, I think, 2 years ago now, maybe? He's a nationally ranked archer, bow and arrow guy. So he's sponsored by, like, yeah, it's pretty cool. He'll never go hungry in deer season. Sorry.
I'm not.
Or turkey season. Is that better?
Vegetarians.
Whatever.
I am offended.
You'll get over it. What happens is he brought in his laser sights when we did that lab in geometry a couple years ago. And when we were using just the protractors with the paper clip and just measuring stuff out with a straw, we were within a couple of inches what his high-tech multi-$100 device was doing with a laser. So it's just kind of cool that this is actually.
Lasers are cooler.
You're right. Sharks with lasers are even better.
Don't even mention sharks.
Now, again, when you're looking up towards an object, this angle of elevation is off the horizon going up. Okay, is your horizontal distance. An object that you're looking at, it also has some imaginary horizontal line that happens to be parallel to the imaginary horizontal line that you have. And when it's looking down at something, it's called an angle of depression. Angles of elevation and angles of depression are congruent because two parallel lines cut by a transversal, you have dun dun dun.
Alternate interior angles.
Alternate interior angles that are congruent. Okay? It's all comes back to haunt you, I know. You guys are very excited. So without any further ado, let's look at what this is.
Only word problems.
These are fun.
Could we have more about like people with measles and stuff?
Now we'll do this one. This one's a fun one. I haven't done this one yet today.
Will we use CPCTC?
No, you're not doing proofs of this one. Don't worry about that. It's just.
Yeah, we're not doing proofs again.
No. I shouldn't say you're not going to do proofs. You will do trigonometric proof in about a month. Here we go. I'll just read it out loud so you guys can kind of figure out. I did not get a chance to run these off, otherwise I would have. So, A ramp is needed to allow a vehicle to climb a 2-foot wall. The angle of elevation in order for the vehicle to safely go up must be 30 degrees or less. The longest ramp available is 5 feet long. Can this ramp be used safely? So think about a logistical problem that you may come across in your real lives. You may be out, camping or off-roading somewhere.
Why do I know that much about angles and measurements of a ramp?
Because you never know. Because you could be.
Vehicle safety book.
Well, you have your vehicle safety book. You're right. And departure angles and stuff like that for anybody who's gone off-roading.
Whoever cares about safety, though.
Yeah, but it's. So it's completely possible.
Why would you put him a 2-foot wall?
It's completely possible that you're out driving around in the meadow and you come across a stone 2-foot fence. And you're like, no! And you can't go around the fence because the fence is so long, it's like Texas. But that's the idea. You got to back up so you want to safely go over the fence. It doesn't tell you how you're going to get on the other side of it. You're going to jump the fence. We're getting all General Lee on this. So here, Deuce has your reference. Thank you. So you have this 2-foot wall that you have to climb. You're driving down the road, but the ramp that you have is only 5 feet.
Oh, the top is fine?
Oh, I put the 5 in the wrong
I put the
spot.
5 on the bottom.
Oh.
Now, will this be safe enough for you to be able to drive up the ramp, go, and it flies
When
away?
you get to the other side,
Is it gonna be like grease?
It
Flying in the sky?
doesn't say. You just have to assume that you're just going to jump. You're going to jump you're jumping into the river.
This map doesn't jump the shark.
you can barely like one line.
Mr. Murphy, can you put a shark in there so
Yeah, I know.
this map class jumps the shark?
So laser shoot. Now, that's actually section 13.7. We do projectile motion. Now, what trig function do you have to use to figure out theta?
Reverse
That you
sine.
taught us yesterday.
Something I taught you yesterday. Good.
Inverse sine.
And then he died.
And then he dies. Yes. Yes. You kind of drown and die. Yes, it's a happy camping trip. What trig function do you have to use?
Inverse sine.
I have to use sine. The sine of theta. This is what's different from what you saw last year. We use theta a lot now. No, just nod and smile. Is 2/5. How do you find the angle then? What button do you have to press on the calculator?
Inverse sine.
Sine with the -1. So your angle is sine of the -1 of 2/5. Okay? Make sure you're in degree mode. Press the button that says mode on your calculator. Yeah, because you weren't here to tell you. And what do you get for your angle? 23.56 degrees. Now, does that mean we can safely go up this ramp?
You go up the ramp.
Yes.
You can make the ramp even
If
longer.
you hit the button that says mode, you want to change it to degrees? I'm just trying to help you. So basically, another way of thinking of this, have any of you guys ever seen a boat ramp?
Yeah.
A boat ramp is set at a specific pitch, so that way it's safe enough for vehicles to drop the boat down and bring the stuff back without getting stuck.
All right.
Okay, you guys don't care. So
cool.
there's math everywhere. Shiver me timbers.
There's map.
Normal people don't have to pay attention to what math.
Normal people also like to talk.
That is map.
Was that even a full insult?
I lost it. I just gave up. All right, so you have an airplane. We have an airplane that takes off a mere 200 yards in front of a 60-foot tall building.
Oh, God.
That sounds like a great place to put a building.
What if you miss?
It's a bad day. It's also an orphanage. and
They are dead.
Oh my god.
And the Humane Society.
It's a tail, slash, there's an arrow in his name, slash, okay, then, slash.
And Sarah McLachlan is in there singing to you right now. Anyway, all right, so. I don't think I'm that funny. This is just absurd.
I have a question. Why don't we take the building and put it over there?
Anyway, there are. Hold on now.
Hold on.
This is not drawn to scale. You're right.
Why can't you just get a building?
We're trying to find out the high. Search orphanage.
Ooh, a plane.
Dad?
It's a plane. It's a plane. It's a planer. It's a plane.
Corners and stuff? How do you know that?
Because he's a normal human being.
No, because I would sit in the basement for hours on that.
There it is, the Spitfire.
All right, we'll use the Spitfire. Anyway, so you have an airplane. It's 200 yards away from the children. The building is 60 feet tall. Right off the bat, you should notice that you have two different measurement units.
The plane is 30 feet.
You want to make sure that your units for your triangle are the same. I always recommend working to the smaller of the two units because it becomes easier with the calculations a lot of times. You don't have to worry about fractions and decimals and stuff.
So it's 600 feet.
Correct. How did you figure that out?
Because they are.
There's only very few conversions that I expect you guys to know. 12 inches in a foot, 3 feet in a yard, 5,280 feet in a mile.
Yeah, I don't know that.
Well, you better. 5,5280 feet mile.
Okay.
We speak English well.
I caught that.
That was actually
Sorry.
That was actually easier to remember.
You know, you use well.
Good job on me.
So now it's 600 feet there. We need to figure out what is the safe, constant, and or.
I think they should.
Mom's so scared of nuclear warfare. I think they just need to give up and crash into the building.
It's gonna bounce back.
Invisible wall.
Whoa! Whoa! Looks the red bear's gonna get. Whoa!
Okay. Looks like
What trig function am I going to use? Tangent. In this case here, do you need to worry about simplifying fractions before you do anything? No, it doesn't matter at all. Your calculators can do all the work for you, so that you don't have to worry about simplifying anything. Okay? Thanks.
5.7. I don't think I did this.
All right. So how do you type it in your calculator?
the inverse tan.
5.7.
So it needs a degree of 5.71 degrees to safety. It doesn't seem like a very steep incline.
Wait, what does that mean? It exactly close the building? Because we don't know how big the plane is. It could easily just crash in the corner.
Degrees. It's supposed to be degrees. Okay?
Can't we just say?
Not so scary, I'm assuming?
I got it.
Now we're really scared.
Is it 6?
So the plane is going to hurt.
I think I want to do one.
I was scared for this. I won't do it in any of my other classes. That's where
Yeah, we'll do the other stuff now. All right. So here's the other part. Good old-fashioned law science.
Angles of depression.
So the other part of today, like I said, I wanted to do is go over the law of sines. Now, law of sines, if you guys remember, is for solving.
Also back in the mail. If I'm like one of those.
Showed up and he was like, what?
I didn't quite catch it the first time around. You gotta help me out again.
No.
You sure?
Yep. We're good. Like to raise with like one.
I still think, I was just talking to Miss Denny about this, I still think one of the funniest things when we taught our kids, animal sounds, because you do, we taught what a shark sounds like. Sorry, we had to ask for my kids, what's a shark sound like? They go, They have not seen Jaws, nor will they for a long time, but it's just kind of fun to. Oh yeah, it's awesome.
It was back in the day.
It's like
It's-
ketchup.
I'm surprised that
It's
wasn't
just
rated
that
R.
giant.
Go back to making your whale sounds, it's all right. Okay. So, law signs. Like I said earlier, this is review from what you did last year. When you're working with law of signs, it allows you to find side lengths and angles of a non-right triangle. What we're going to work on today is going to be all the same stuff like you did last year. Nothing really changes here. So you wind up these three ratios. The sine of an angle is to the side opposite, as the sine of another angle is to its side opposite, as to a sine of the last angle is to its side opposite. Obviously, you're not solving for all three of them at the same time. You're going to reuse one of them to solve for each of the other missing parts. Don't worry about this equivalent form of it just being reciprocal. I never use it. There's no point. I mean, it's the same thing, okay? Law of signs, like I've said, is very, very easy to use. So let's just jump to a couple of examples with this, and I'll probably just let you guys get started. Why are you stabbing people? Separate those two.
The bad corner is just like the.
No.
It's like a shank film.
So here's what they look like. If you recall from last year, you'll have something like this. It says solve triangle ABC. And it gives you two angles and a side. What do you think your best bet is to do to start this problem? Draw a triangle.
Let's try. I can't do stuff.
It works, but we don't do it. Because it's quicker to use trick. It's quicker to use trick. Soak it toe up.
Oh, I made it already trying to add screw it.
You just label out your parts, okay? So you're given angle C is 103, angle B is 28. And little b is 26. If you look at the diagram now, you'll notice that you have one set of angles and sides opposite one another at B. And the way that I set these things up is I like to circle what I'm using as what I call my pivot. I'm going to use those values to solve for both side A and for side C. I'm going to reuse my givens. It's a very, I've been stressing this with a lot of the trig stuff when you're solving right triangles. You want to try to reuse your givens as much as possible, just in case you screw up, you don't screw up again. All right, so it's very easy to do that. So we just write it out. Sine of 28 is to 26, as the sine of 103 is to C. This is nothing more than fraction equal fractions. What do you do?
Cross multiply.
Now,
So hard to ask.
so you get 26 times the sine of 103 is C times the sine of 28. Remember, the sine of 28 is just some crummy decimal, right? So how do I undo that? Good. This chunk right here is your side C. put it directly in the calculator exactly like that. Do your alpha y equals, and there was it 26 sine 103 over sine of 28. And then enter. The calculator does all of it for you. But write down what you're doing before you do it.
Are we running it to the one place after the decimal?
I always go hundreds. Always go hundreds. Okay. So 5396. Okay. So my side C is 5396. How do you figure out angle A? Just subtract the other two angles from 180.
Oh, yeah.
Okay. What do you get? 49. Now, reuse that B and angle B. So you have the sine 28 is to 26 as the sine 49 is to A. And you might notice that this setup is identical to the equation we set up for side C. So a lot of times you can shortcut your work just by recognizing the pattern. Or just multiply it out, and it takes a second.
Could we use Pythagoras here?
Is that a right triangle?
Oh, no.
So can you use it?
No.
Very good. So what do we get? 26 sine 49 over sine 28.
I think it's sine 20. Or no,
What do you guys get?
41.8.
41.8? Yeah, that's what we got earlier.
Spoiler alert.
Now, I know since you guys don't have answers in front of you with a lot of these things, you have to kind of look at your response to try to see if the answer makes sense. Obviously, there's one thing that you could do just to kind of briefly say, maybe. What's the relationship between sides and angles?
The biggest angle has the longest side.
That's a lot of times it's the best thing you can do is just take a brief second and check to see if the largest angle has the largest side, medium angle, medium side, small angle, small side. If that happens, you're probably okay-ish. Okay. What? Let me give you another one. I can grab the reference. Solve the triangle, please. What's that? Solve the triangle item, please.
Big letters or angles, right?
Big letters or angles. About the right same spot. You guys. Draw your triangle. 105, 11, 5. This is forcing me to find what angle first? A. It's forcing me to find A. So I have the sine of 105 is to 11, as the sine of A is to 5. Now, think of it in terms of just dividing by 5. How are you going to do that? Multiply by 5. So you get 5 times the sine of 105 over 11 is the sine of A. Now, this 5 sine 105 over 11, just some crummy decimal. Do you agree?
Yes.
In order to find the angle, you just inverse it. Set in sine. In your calculator, you type it like this. We have 5 sine 105, hit enter, divided by 11, hit enter. You get this decimal. Second sine of your answer, enter. There's your answer, 2604. Okay? Don't round it off until the very end. The calculator stores it.
At this point, do we have to use that angle because we can't figure out the third?
Yeah, you have to use the angle in this case. So this, I mean, I try to say to reuse your givens as much as you can, but this, in this instance, you do have to reuse, you have to use something else. So it's 2604, and then you get that to find C, and then you just use loss signs again on the other side. Right. Yes, ma'am?
If we do rounding to 26.1, we take off the back.
Because then when you compound it to the next one, you're going to be off by like a full digit. So try not to round it to the very end. Use that second answer. Okay. All right.
Can we just use the 180 minus the angles to find the other angle?
Well, you have to in this case. There's nothing else you can do. All right. You have to hopefully get this one right, because you kind of have to do that. There's no other way of doing it. Okay. What'd you guys get for C then? It's 131. So it'll be
Which C?
this one, big C.
49.
48.5.
Because if it's 49, then you have more degrees than a regular triangle would.
I rounded down.
Two decimal places, sir. You think you're going to land on the moon if you keep rounding off like that? Jeez.
You'll go flying
You
off
go
into
far away.
space.
He's
It'll be
like,
like,
no!
it'll be like,
He said, "I was like, no, I'm going to go to the moon."
it'll be like the movie Gravity. It'll be like George Clooney and you'll die.
Thanks. Haven't seen it yet, jerk.
Oh, sorry.
What
Spoiler alert, George Clooney dies.
Not going to rent it now. I wasn't going to watch any of this.
Spoiler alert, George Clooney dies. And that
Her looks like it's
struggle for life.
Questions on this? We'll get to the weird cases of law signs tomorrow. Let me give you two sets of problems
Wait, we're
though.
watching Wall Street.
Ah, you can figure that out. Nope.
Figure out what? AJ, you know. Sam Shore, how much hold on.
Make the joke. Well, then tell it.
Do you think there's no we should go tomorrow?
Yeah, we'll be here tomorrow. All right? Yeah. Yes. It's just the first. I don't think we did it. Oh, that's right. You know what? I'm sorry. What happened was that we were going to do the modeling stuff, then we realized that there's a whole nother modeling unit later on, so we're just going to wait to do it. We're just going to wait to do it later. Well, we have to, but we'll just do it later. It's no big deal. I'm sorry. I thought that's what we were doing. Wow. Yes, ma'am.
I couldn't see any of the problems. Dropped out. I rolled up on the board. On the board.
On the doctor's note, I got this box that said student needs to do half day.
That's the secret reason why I'm mean to you.
I just pen and marker.
You should have. I know.